Hey everybody, this video lesson is going to cover a concept known as dilution. You might have heard the concept of dilution in terms of something known as watering down, and that's essentially what we're going to be doing here today, but we're going to be doing so quantitatively with actual data. A dilution is a process of becoming less and less concentrated, and you can see in the picture here that we start with a concentrated solution. We call it 100 molar, and then this is 10 molar, and then this is 1, and then finally 0.1 and 0.01. And you can see by the color is changing and becoming lighter and lighter as you become less and less concentrated. This is basically a series of solutions that is less and less concentrated. We call a dilution. Now the word dilution could be a noun or it could be a verb. To dilute means to make less concentrated. A dilution is like a process or describes a series of events that make less concentrated. So it can kind of describe an individual situation or a series of situations all at the same time. Now there are two ways to make a solution less concentrated. One way is to decrease the amount of moles of solute, and the other would be to increase the solvent. Now decreasing the moles of solute once they're dissolved is incredibly difficult to do. You actually have to go in and remove the solute without touching the solvent, and that's just impractical. So rather what we do is increase the amount of solvent that goes into a particular sample to dilute or water down, and that's where the term watering down comes from, water down the sample to become less concentrated. Now before I show you how to do this, it's important that you know another vocabulary term, and that's stock solution. Stock solution is what we consider the most concentrated, and in a minute you'll see we designate the stock solution as the most concentrated, or molarity number 1, or highest molarity. Now the formula for dilution is located up here at the top. It's M1V1 equals M2V2, where M1 is defined as the molarity of the concentrated, or what we just defined as the stock solution, and V1 is the volume of the stock solution. M2 is the molarity of the dilute solution, and V2 is the molarity of the volume of the dilute solution. Now in these problems, you'll be given 3 out of these 4 variables, and you'll be asked to solve the missing variable. Now here's a scenario for you. On the left-hand side, I've got a 10 molar solution of blue liquid. It has 10 moles per liter. And I'm trying to figure out what volume of it do I need to put into this beaker, and so that I have a 10 milliliter sample and that concentration is 1 molar. And I set up M1V1 equals M2V2, where 10 molar is my initial molarity and my volume 1, and M2 and V2. Now what I'm going to do is use basic algebra to solve for V1 by dividing by 10 on each side. Now when I do that, 1 times 10 divided by 10 equals 1 milliliter. So that tells me that's the volume 1, or the volume of my first solution. So I'm going to use a graduated cylinder, and I'm going to suck out 1 milliliter and put it into this beaker, or this graduated cylinder. I'm going to transfer that to this beaker. Now my final solution needs to be 10 milliliters total. I've already put in 1 milliliter into this new beaker. Now remember, V2 is total volume of the new solution, not how much of the water I add, but total. So if I've already put in 1 milliliter of the stock solution, then I need 9 additional milliliters of water. And so I'll take my graduated cylinder and I'll use and fill it up with 9 milliliters, and I will dump it in. And now you can see that it's clearly been diluted because it's less blue. But I use M1V1 equals M2V2 to calculate how much of the stock solution I need to then place in the new beaker. It's important to note that when you're actually calculating V1 and V2, to know what they really stand for. You need to take V2 and subtract V1 from it in order to figure out how much water needs to be added to the new solution in order to make your dilution. If you were actually going to do this in lab, you would need to calculate out first how much water needs to be added, and then measure it out and add it to the volume of the stock solution that you added to the second beaker. So in summary, if you take the volume 2, which is your volume of dilute solution and subtract volume 1, which is the volume of the stock solution that you use to make your diluted solution, you should determine how many milliliters of water then need to be added to the second beaker in order to reach your final volume, or V2. So here's a practice problem involving M1V1 equals M2V2. Let's take a look at what we've got. We've got a 12 molar concentrated HCl solution, and you want to make 250 milliliters of 3 molar HCl. What volume of the 12 molar do you need? Well, if M1 is 12 molar, and the V1 is what we're trying to find because it says what volume of the 12, then I put those next to each other on the left side of the equal sign. Now M2, which is a dilute solution, is 3.0 molar, and I want to make 250 milliliters of that new solution. So using basic algebra, I'll take and divide 12 on each side, and I'll get 62.5 milliliters, and that's my V1. Now, if my final volume is 250 milliliters, and I take 62.5 out of the 12 molar and put it into a new beaker, the follow-up question says how much water do I need to add to make 250 milliliters of solution? So, as we just talked about, you take V2 minus V1 to figure out H2O added. So V2 is 250, and I subtract V1, which is 62.5, and that should give me the milliliters of water added. And that number is 187.5 milliliters of H2O added. This last problem is a little bit more complex because the first bullet point actually gives you some information to actually make your stock solution. And so let's do it. It's a basic molarity problem. So molarity equals moles over liters. If I have 269 grams of CuCl2, I can use the molar mass to figure out how many moles of CuCl2 I need to then put in the numerator. And I'll use my periodic table and I'll find that CuCl2's molar mass is 134.45. And if I take 269 divided by 134.45, I get 2.00 moles. So I'm going to put that on top. I'm going to put 2.00 moles on top, and I'm going to divide by 0.5 liters of solution, which is the same as multiplying by 2. So I have a 4 molar solution, and that's my M1. Now the second bullet point says how many liters of 0.25 molar CuCl2 solution can you make from this stock solution? So I'm going to put a line here and I'm going to do my second problem now. It says how many liters? So my M1 is 4 molar. And my V1, as I already established in the first part of the problem, my volume is 0.500 molar, or excuse me, 0.500 liters. Now how many liters of 0.25 molar can I make? So I'm actually asking to solve for V2 this time. Now if I do basic algebra and divide by 0.25 on each side, X is going to equal 16.0 liters, and that's my V2. Assuming you take all of the stock solution, all 0.5 liters, the 4 molar, 0.5 liters, and you want to dilute it all down, add enough water to get down to 0.25 molar, what would be my new volume? The answer is 16 liters. So it's slightly different than the other one. We were solving for V2 this time rather than V1. V2 is new volume, V1 is initial or stock solution volume. Now there's lots of different applications of doing dilutions. These are just a couple. We'll do a lab on this. I hope you enjoyed this. Thanks for listening.